Hello, my name is Miss Perry, and I wanted to share with you just a little bit about what goes on in middle school science at K-12 International Academy. So I have a few snips from my class connects where students are participating and we are doing some fun activities and some fun labs. So this first video here, I'm just going to play a couple minutes of our class connect session where we are looking at structural geography and plate boundaries.
Alright, so we're ready to get started. The first thing that we're going to talk about is forces within the earth. So, if you take a rock, if you were to pick up a rock, you're probably not strong enough to pick up a really big rock, or even a smaller rock that you could pick up. Just by trying, you're not strong enough to bend it or break it by pushing on it and pulling on it. So, these changes in rocks take very strong forces and a very long time to bend and break. So scientists, instead of actually doing this with rocks, they make models to study the effects of stress from forces within the earth. So that's what we're going to do today, is we are going to make a model of folded rocks. We're going to simulate those forces that cause faults, and then we're going to work in the field observing examples of faulting and folding on the earth. So, stress on the plate. So we know that there are 12 main plates that make up the tectonic plates within the earth, and then there's a lot of smaller ones. But all these plates fit snugly together. Many are quite large, such as North America sits on one big, huge plate, and it's actually bigger than all North America. So these plates are really big. If one plate moves or a force is exerted on just part of that plate, it may push on other plates or pull on another part. Or within the same plate, there may be forces pushing and pulling. So this is going to cause 3 different types of stress on plates. And I know you can see these words really good on this slide, but we'll go over them. They are compression, tension, and shear. Those are the 3 things that we need to, the 3 words that we need to learn today. Compression, tension, and shear. So what are these definitions? Compression is when the rocks are squeezed together. So if you were to take a rubber band and start squeezing it together on either side, that would be compression. Tension is pulling apart a rock over a large area. That is tension. And then shear is pushing the rock of the crest into opposite directions. So one side's going one way, one the other way, alongside of each other. And it results in a simple bend or break in the rock. Any questions on any of these definitions here? Compression, tension, or shear? All right. We can also kind of correlate these with the plate boundaries, right? So we have 3 different types of plate boundaries. We have convergent, divergent, and transform. So what would you correlate compression with? Squeezing together. What type of boundary would you correlate that with? Convergent, divergent, and transform. What would compression be like? Good. Pushing them together, yes. And which boundary is that like? Is that like your convergent boundary, your divergent, or your transform? You've got it. Good job, try. Yes, it is your convergent boundary. Now the difference between what we're talking about today, it can happen at a plate boundary, but like I said, it can happen within the same plate. So we're looking at forces that can happen in the middle of the plate, or it can also happen at plate boundaries. But plate boundaries would be if 2 big plates are moving together, that's a convergent boundary.
Also in this class connect, we did models using clay to model these faults. They labeled the hanging wall and the foot wall, and then we noted which direction they were moving in order to determine what kind of faults they were seeing. So here's just a little snip of that.
Fault compression makes this move up. And I have a reverse fault. Okay, let's do our normal fault. Return the pieces to their original position. Slowly pull block B upward while keeping the joined faces in contact. So the hanging wall now is going to now move down. You have just
We then looked at examples in the real world and determined what type of faults had happened or occurred in the real world examples.
All right, here's our second one. Example B. Where is our fault line? Where is our hanging wall? Where is our foot wall? Oh, the real world. I got the first and last. Good. This is our foot wall. This is our hanging wall. So which way did the hanging wall move? Good. Up. These two lines used to be connected, so we can see that our hanging wall has moved up. So what kind of fault is this? Reverse. Awesome. And what type of force did this? Compression. You guys are on a roll. So make
We do other really fun things in our science class. You can take a look at this PowerPoint screen down here. You can see other activities that we've done in our Class Connects, like our erosion activity. We've made recycled paper. We do our seismograph lab. All of that we do together in Class Connect sessions. One other thing we did with our solar system is we made a scale model of the solar system, and so you can see that live in our Class Connect session over here. I had asked the students, first we made a prediction, and so I'm going to play.
All right. So here's my Earth and Moon. Here's what I would think. And then think about how far apart are they? Are they this far apart? Are they this far apart? How far apart are your Earth and your Moon? Awesome. Right here. All right. And what you would do.
And so there was our students making their predictions with their Play-Doh on camera, and then we went on to make a scale model, and we saw how far off our original predictions were to our final models. So that's just a little snip of all the fun that we have in our middle school science class connects. Thank you.